Hi everyone, in this video I'm going to go over how to use YOLO V8 to understand novel object interaction with the mouse. And if you have not used YOLO V8 before, don't worry about it. I'm going to go through the entire process step by step, and you can follow along if you like. So first step is to open up your Anaconda and get everything set up. Here I'm going to go ahead and install my YOLO V8 environment. So you can go over to Ultralytics website and go ahead and follow their instructional tutorial, or you can go to my GitHub page and you will find instructions like this over there. And I will leave the links to these websites down below. So I'm going to utilize my GitHub page and copy paste the instructions from there. First thing I'm going to do is extract frames from some videos that I have. Here I'm testing if I have the FFmpeg installed, and you can do that using this command line. And so if you see a message like this, that means you have successfully installed your FFmpeg. If you don't have it, don't worry about it. I'll share the link below. You can go ahead and use that link to download FFmpeg. If you have it, then go ahead and use the command that you see on your screen and modify this a little bit to put in the name of the video that you want to have the frames extracted from. So here I just put that in there. I copy pasted my name of the video, and here I'm inputting that name as the output path. The code snippets are on my GitHub page, so you guys can go ahead and copy these from there and utilize these for your own project. So once I have these, I'm going to go ahead and put my name, the video name, in the quotation mark, and then pressing enter will go ahead and run the code, and on the left you can see the images are populated in my folder. So these can go into a folder called images, and I'm going to go ahead and create that folder. Here I'm going to label it images. I'm going to go ahead and create another folder, called that labels, and move all of my images into the images folder that I just created. Okay, so now I have two folders, images and labels. I'm going to make another folder. This one I'm going to call, this will be called train, and I'm going to make another folder in the root directory called val. Now training folder is going to be used for training. Inside of the training folder I need to create two folders, one called images, the other one called labels. So respectively these are the folders in which the training images and training labels will be stored. Then into the val folder, and here I'm making the two folders again, images, and this will be labels, and this will be used for validation of images. And I've placed a picture on the screen to show you what the nested structure of the folders looks like. And after making my test folder, I'm moving the images and the labels folder from my root directory into the test folder. And this test folder is going to go inside of a dataset folder. And guys, you have to label your folders like this, otherwise it will not work out so well. Let's go through this again. So here I have images, and these are the images that I extracted, and then in my labels folder I have nothing right now because that's where I'm going to store labels. This is embedded inside of a test folder, which is embedded inside of a dataset folder. So this is the structure for the dataset folder that you need to have. I'm going to utilize label me to annotate my dataset, and if you don't have this, please utilize pip install label me to get this software installed. It will help us annotate. So here I'm navigating over to my images. These are the images that have been brought into label me, and I'm going to go ahead and utilize automatic save and then change the directory for my labels to the labels folder within my test folder. So all of the labels are now going to be saved in the labels folder within the test folder that we had created earlier. So utilizing automatic segmentation tool like the Efficient SAM here, I'm going to segment out the mouse from the background and label that as mouse. I'm also interested in labeling these petri dishes. These petri dishes are going to be my left and right novel object in this example, but for your own data set this may be variable. Nevertheless, you can utilize this example and understand the basics of how to use YOLO V8 to do your novel object interaction analysis. And here I'm going to go ahead and quickly finish labeling all of my data set, and then I will show you what to do next. Alright, so my data set is labeled. I've closed my label me window, and here I'm just making sure all my labels are saved. And then I'm going back to my root directory here. And now I need to convert the labels to a format that YOLO can read. And to do that, there's a command line for it. And this will be in the description below, and you can find this on my GitHub page. Alright, I got an error because I don't have the label me to YOLO installed, so I'm going to go ahead and pip install that. So again, a great example of when you don't have something installed, just go ahead and install that as you're working through it. So utilizing the label me to YOLO, I have converted my labels over to a format that YOLO can read. And utilizing copy paste, I'm moving things from YOLO dataset folder over to folders in my root directory. So here, for example, I'm moving these images to the train folder images, which was the train and the val folders were created in the root directory, and from YOLO dataset folders I'm moving my things to the val and train folders respectively. So once you copy paste the images to the images folder within your train and val folder respectively, do the same thing for the labels. Alright, so next we are going to utilize we're going to utilize this dataset YAML file and change some of the things that we need. I'm going to paste the path to the train folder in my root directory, and I'm going to copy and paste the path to the val folder for my val folder directory. Make sure there are no parentheses or quotation marks around those paths. Alright, so now we're ready to utilize this dataset YAML for training. So the command for starting the training is also on my GitHub page here. You can copy this and paste it. You will have to change the name for the dataset file, and I'll show you. Here I've cropped out a section of my screen where I'm emphasizing the changes that I'm making. Here I'm changing the dataset name. Make sure you put in the dataset YAML file name that you have. And once you have this, you can press enter and it will start to run, go through its own processes to run the training. I'm going to go ahead and pause it here and come back after the training is done. So the training is done. It took literally a few minutes, and it tells you how much time it has taken. So maybe 8 minutes for me. All right. So then once the training is done, there are a couple of things we need to do. So here's a Python script that I made. This is going to help me extract information about the intersection of the mouse's rectangle, so bounding box for the mouse, and the overlap with the novel object. But before that, let's go ahead and utilize the best trained model and change the model path in the script here. And then I also need the video that I'm going to utilize. So here is a new video that I'm going to use. This video has not been shown to the model for training, so it will be a very good indication of how the model is doing. So a couple of other things you can change. For example, the minimum duration the mouse has to interact with your object to be able to count it as an interaction. I've set to be 5 frames. I think that's fair, but change that based on your own scientific justification. So to be able to run this script, make sure you're in a correct path where your file is saved. Then type in python-m and then the name of the Python script itself. Remember, the script itself, we already put in the model path and the video path. So the script will know which video to run and which model to utilize. After it has done its execution, it will print out 2 numbers for you if you have 2 objects like I have here, and then you will be able to see the 2 output CSVs and this AVI file. The 2 output CSVs are for each of your object and the number of interactions and frame duration for the interactions. So here, for example, I paused it and you can see up here it's interacting with the right petri dish once and it has marked that as an interaction. So guys, this is how you utilize YOLO V8 to do novel object interaction analysis. Guys, please remember this is just an example and your own experimental needs might require a different approach. For many people this would work, but for some of you who are doing complex analyses, these approaches may not work. So guys, that's it for this video. Thank you so much for watching.